Okay, solving equations. Just as a reminder, there are a few little notes to self we need to take mind of. So in our top right hand corner, we're going to put our little note to self, our little N2S. And let's say we've got to, first of all, remember the opposite operations. Keeping in mind that there are only 4 mathematical operations: add, subtract, multiply, and divide, and that's what we're going to use in order to solve equations. So I'm going to start off with add, and the opposite of that is to subtract. The opposite of multiply is to do what? Divide. And just so we can look at it for day one, just to have it to look at, let's write it the other way. If I have a subtract, the inverse or opposite would be to add. And if I am dividing, the inverse or opposite operation would be to multiply. Okay, so this is our first note to self. Just as a reminder of how to solve equations. Now, our goal in solving equations is always the same. Always the same. We're going to write this across the top, our goal. And then I'm going to try to spell it correctly. Our goal in solving equations is always the same. We're going to get the variable alone. I want that variable on one side or the other. Could be left, could be right, but I want it to be alone. Nothing with it. Okay? So in order to accomplish that, we're going to have to move terms. We have to move some terms to accomplish this goal. So moving terms is this. First, we always move addition or subtraction. Always move addition or subtraction. And then secondly, we're going to move multiplication or division. Okay? So that's another little piece to our note to self. And then before we begin solving them, our final little note to self is this. We're going to use the inverse or opposite, keep in mind those are the same thing, use inverse operations to move terms across the equal sign. Okay? You cannot just move things however you want to. We must use inverse operations or opposite operations. Okay? And now that I've said both of those, I'm going to go back up here to the top, and where it says opposite, I'm going to put inverse, so that you know that those are synonymous, they're synonyms, and I'll be using them interchangeably. Let's begin. So looking at number 1, the first thing we have to decide is what operation do we have going on in number 1? Well, first of all, find the variable. So I'm going to use my green highlighter, and I'm going to find my variable, and right there it is. My variable, I want it to be alone on the side it's already on. So my variable is K, and it's on the left-hand side, so I want it to stay there. I also don't, so since I'm not moving it, I'm going to cover it up, and I'm going to move everything else. Well, I've got a plus 8. What's the inverse of plus 8? Minus 8. Minus 8 to the opposite side. That makes this a 0, because 8 minus 8 is 0. And now I have 7 minus 8 is a negative 1. And then I bring down my equal sign and my k divided by 6. This is a fraction, but keep in mind it's a division. So the inverse of dividing is multiplying. When I multiply, I'm going to multiply the numerator by 6. Always put the parentheses around what's already there. And I'm going to multiply my negative 1 by 6. 6 divided by 6 is 1. And now my final answer is k is what's left, equals negative 1 times 6 is a negative 6. And that's our final answer. Okay? Now, number 2 is the same type of problem. X is on the left side. I'm sorry, it's on the right side, so leave it there. All right, let's look at number 3. I have negative 70 equals negative 7 times n plus 1 plus n. Now, another way to do this, if it helps you out, to determine your sides, just draw a line through there. Draw a line separating your sides. Okay? So now I know what I'm working with. First thing I have to do on this side is I know I have to distribute. So I'm going to do that now. Negative 7 times 1 is a negative 7. Negative 7 times n is a negative 7n. Of course, on this side, all I have is a negative 70, so I'm going to bring that down. Now, I can start working on getting that n alone. So here's my n. It's on the right-hand side. I'm going to leave it there. I'm going to cover up the n and the number it's connected to. Always remember that your signs belong to what's to the right of it. So now what I have is a negative 7 or a minus 7. The inverse of that would be to add 7 to the opposite side. Negative 7 plus 7 is 0. So I have negative 63 equals negative 7n. Now, if you are used to writing that plus 7 under here and putting the 0 on that side, I'm okay if you write that extra step, okay? But I need you to know that as long as you do the opposite operation on the opposite side of the equal sign, you are making the same step, okay? So now, negative 7 times n, what is the inverse of inverse of multiplication? Well, it's division. Divide by negative 7 on both sides. That becomes a positive 1. N equals 9. And we're going to circle that final answer so it stands out. And as you can see, number 4 is that same type of problem, so you can practice that. Now, let's look at number 5, because number 5 is a little bit different here. It looks differently. What I want to point out here, I'm going to go ahead and separate my sides with just drawing a line through there. When you have an entire side that is a fraction, we're going to make it not a fraction anymore. So how do I get rid of the denominator? Well, this is, again, division. The inverse is to multiply. So I'm going to multiply that 2. And as a reminder, what is already there gets the parentheses. What's already there gets the parentheses. So I'm multiplying by 2. 2 goes into 2 one time, so I can just mark those out. Then we'll go to the other side, and I'm going to multiply the 11 by 2. Keeping in mind what's already there gets the parentheses to show multiplication. Remember, these parentheses show multiplication. So I've got 22 on this side. The denominator is now gone. What do I have left here? 8 plus a. I have found my variable. It's on the left side, so leave it there. And we're going to cover it up and its operation. And what I've got is a positive 8 here. How do I get rid of 8? That's right. We're going to subtract 8. And again, I'm going to write what I was talking about a second ago. You can subtract 8 here. So you can still subtract that 8 from both sides if you need to do that. That still makes a 0. But notice how I did the minus 8 on this side, so it would have eliminated it already. And now what I have here is a positive 16 equals, well, okay, so let's subtract correctly. I apologize. 14 equals A, and that's my final answer. Get rid of the denominator by multiplying it away. Always do that first. Okay? Looking at number 7, highlight our variable. There's my B. Oh, wait. There's a B there also. So this is variables on both sides. When I have that same variable on both sides of the equation, separate those sides, I've got to get the variable on one side. This is an entire term, so I'm moving the entire term. So I know that negative 4 is multiplied to B, but I'm not trying to remove the 4 from the B. I'm trying to move the whole thing. So it is a subtraction, and the inverse would be to add 4B to this side, which would eliminate that negative 4B there. And what I have left is 1 plus B equals negative 4. So once I have the variables, and we'll make a little note over here, get the variable on one side. That is step 1. Step number 1. Step number 2 is to get the constant on the other side. Okay? So get the variable on one side, get the constant on the other. Therefore, I'm looking at this B, and it is on one side now. So move that constant over. How do I get rid of a positive 1? Well, I'm going to subtract a 1, and I'm going to subtract a 1. There's my 0. B equals negative 5. And that is our final answer. Okay? Now, in number 9, we have the same situation where I have K on both sides of the equation. Now again, how do I know that that's both sides? Because the equal sign separates the sides of an equation. So step 1, get the variable on one side. So I like my variable to the left, so every chance I get, I'm moving it to the left. Well, this is a minus 7K, so I'm going to add 7K over here, which is going to eliminate the one on the right. And what I have now is negative 10, negative 7 plus 7 is 0. It's not K, it's 0. It's all gone. If I had 7 Ks and I took 7 Ks away, I got nothing left. So what happens when the variable goes away? The variable has been eliminated. So we have a special case. So now I'll look to see. Negative 10 equal to negative 5. Is that true or false? Well, that's false. So that means there is no solution. So special cases, yes, the variable can be eliminated. And when it is, you're looking at a special case. In this case, it's no solution. And what that means is, if I go back up here and I try to put in a number for K and substitute that in, there is not a number that I can put in place of K or replace K with that would ever make those two sides equal to each other. So that's what no solution means. Okay? So now, let's look at number 10. On number 10, we're going to have to do something first here. Separate my sides. And what do I have to do first? That's right. I'm going to have to distribute that. Now on this left-hand side, there's nothing to combine, there's nothing to do there. So I'm just going to bring that straight down. 8 minus 8m equals 8 times 1 is 8. 8 times negative n is negative 8m. Now, I have found my m's, and they're on both sides. So, I'm going to remove the minus 8m. The inverse of minus 8m is plus 8m to the other side. That is going to eliminate that on the right side, and I have 8 left over. Then I've got negative 8 plus 8 is also 0. So what I have left is 8 equals 8. As a reminder, the variable can be eliminated. Negative 8 plus 8 is not 0m. It is nothing. So we don't write that down. Now, 8 equals 8. Is that true or false? Well, that's a true statement. So when we get a true statement once both variables are removed, we now have a situation where we have all real numbers. Okay, all real numbers. And the symbol for that is a line, and bring an R around. And you are welcome to use that instead of writing it out every single time. But those are our special cases. As a reminder, if the variable is eliminated, then you have a special case. It's either all real numbers, if it's a true statement, if those numbers are equal to each other, or it is a false statement if those numbers are not equal to each other. Okay? If you have any questions, please feel free to email me